Hello all, welcome back. This video is about stack, and in this video we'll cover the fundamentals of stack, operations of stack and its implementations. So coming to what is stack, definition of stack. So it is a linear data structure. That is, that stack can hold or contain data in an ordered sequence. So what is an ordered sequence? Here ordered sequence means order in which we are going to insert the elements, in what order we are inserting the elements. Okay, so based on that order only the elements are getting stored into the stack in a sequential way. So that is what mean by an ordered sequence here. Previously we discussed about linked list, which is an linear data structure, and again this stack is also another example for linear data structure. And here stack basically works on last in first out principle. That is, whatever the last element inserted, that will be the first to get removed. Okay, that is what called as last in first out. We can also say it is a first in last out, which means again the element that is inserted first will be the one to be to get deleted at last. Okay, so that is also called as first in last out, or we can say it is last in first out principle. And here if you take stack has only one in, that is called as the top. Okay, so where both insertion operation and deletion operation happens. And we'll see that structure of the stack now. So this is the structure of a stack. Here you can see this structure, that is a stack structure, is like stack of plates. Okay, so where all the elements are inserted here in this way, like E1, here on top of E1 you can see E2, and then on top of E2 we have E3 and E4. So likewise it is like a stack of plates, okay, arranged. Same way here we have elements arranged into the stack. And if you look at here, so this will be the top of the stack, which always points to the last element of the stack. So this is the last element now in the stack, that is E4. So the top always points to the last element of the stack. So you can see how the elements are arranged in the stack and where the top is pointing to. Whenever you are performing operation like insertion or deletion, both the operations like insertion as well as deletion happens at the top of the stack only. Okay, and we'll discuss this top values by using array and linked list further. Okay, so before that, first we should know what are all the operations of stack. So these are all the basic operations that we can perform on stack, that is push operation, pop, isEmpty, displaying the stack elements, peek and isFull. Coming to push operation, so what is the push operation? Push operation is generally the insertion operation. So when we are inserting any element into the stack, that is called as a push. Okay, so next is a pop operation, which is the deletion operation. When we are trying to remove any element from the stack, then we call it as a pop operation. So as I mentioned, if we have a stack here, okay, this is my stack and it already has an element that is E1. Okay, when I am trying to push one more element into the stack, so as I mentioned already, always insertion and deletion happens at the top of the stack. Now this is my top. Okay, the top is pointing to E1 now, but when I am trying to insert a new element now, which is a push operation. Okay, so when I try to insert a new element into the stack, then the new element gets inserted here on the top, and now this will become my top element. Okay, so the top will be pointing to this element. Now coming to pop. So when I want to remove any element from the stack, I cannot go and remove the element randomly from the stack. Okay, I told you that it is an ordered sequence of elements. So whatever the order you have inserted, so you need to also delete the element in the order only. Okay, so which element is inserted at last, which element is present at the top of the stack, only that element will get popped out first, that is will get removed from the stack first. That is why it is called as last in first out. Okay, so now the element E2 is at the top of the stack, which is placed at the last, like which gets placed at the last order, right? So now this element will get popped out from the stack. Once this element get popped out from the stack, then again my top changes to this position, that is it will be pointing to the element E1 once it get removed from the stack. Okay, so this is what the push operation and pop operation in the stack. And the next is isEmpty. So in this isEmpty, you are going to check whether the stack is empty or not. Okay, so if it is empty, it will return some boolean value like true. If it is not empty, then it will return a boolean value false. And next is displaying the stack elements. What if you want to display all the elements of the stack? Then how do you do it? Okay, how do you display the stack elements? That will be given in this operation. And next is peek. Okay, so this peek can also be called as top, which is if you want to display the element or if you want to access the element that is present at the top of the stack. Okay, then you can go for this peak operation. Okay, this will always return the value or return the element that is present at the top of the stack. Okay, so that is what this operation is, peak, or you can also call it as a top operation. And the last function or last operation is full, where you need to check whether your stack is full, that is whether the stack reaches its maximum size or not. Okay, for that you can use this isFull method. If the stack reaches its full, okay, then you can say that stack is full, that is you can return true. Okay, if it is not, if a stack is not full, then it will return false. And one more thing we need to discuss when we are going for push operation and pop operation. So we have a term called overflow and underflow. So when does this overflow and when does this underflow occurs? Whenever your stack is already full, okay, it reaches its maximum size, and still you are trying to insert more elements into it, okay, more than the size of the stack, still you are trying to insert elements into it, you are trying to push elements into it, then that condition is called as overflow condition. Okay, and coming to underflow, so underflow happens when you are popping the element out from the stack and the stack is empty already. Okay, so when you are trying to pop elements from the empty stack, at that time you will get this condition, that is underflow, because already stack is empty. So in that empty stack we cannot delete any elements, right? So when you are trying to pop elements from the empty stack, then that situation is called as an underflow situation. And these are all the basic operations. Next we will see the implementation of stack. There are two ways to implement stack. The one is array implementation, the other one is linked list implementation. So let's first understand what is an array. We know that array is a collection of homogeneous elements, okay, or you can say collection of elements of same data type. That is what an array, so which can hold collection of elements in it. And the other like property of array is it is a static memory allocation, which means, see, when you when you have given the size, when you already given the size for an array, right, and during execution time, if you want to increase the size of an array or if you want to reduce the size of an array, you cannot do it. Okay, so that is why it is called as static memory allocation, that is during execution you cannot change the size of an array. So you should initialize the size of an array at the starting itself, that is starting point itself. You cannot change the size once you start your execution. So that is why it is called as static memory allocation. And the next one is contiguous memory location. So if you are allocating memory for an array, for example, this is my array, okay, which is capable of storing 4 elements into it. So now the size of the array is 4. Okay, and it is capable of holding 4 elements, which is of type integer. So integer elements means I can say 1 2 3 4. So now this is my array containing 4 elements of integer type. And what are the elements? 1 2 3 4, right? Now these elements are stored into the memory location. And how it is getting stored? In a contiguous memory location, which means, for example, this is my memory location 3010. Okay, for example, I have taken this memory location as 3010. Since we are using Java, so here in Java, if you take integer value, so the size of the integer is 4 bytes. Okay, each integer value takes 4 bytes as its size, right? Now if you take 1 occupies what? How many? 4 bytes memory. Okay, whereas 2, taking 2, again 2 occupies 4 bytes memory. In the same way 3 occupies 4 bytes. So in that case, okay, if my element 1 is occupied with the memory location 3010, then what would be the memory location for 2? Memory location for 2 would be 3014. Okay, and coming to memory location of 3, memory location of 3 will be 3018. In the same way, if you come to memory location of 4, memory location of 4 will be 3022. So each value occupies 4 bytes of memory location, and you can see here the memory locations are continuous, okay, contiguous memory location. It is not like this value is at point 3010 and this value is at the point 4000 and this value is at the point 6000. It's not like that, right? So here every element of the array is stored in a contiguous memory location. Okay, this point you should remember when you're going for like using array. Okay, now we'll see how do we implement a stack using array. See, whenever you are going for implementing stack, the first and foremost thing you need to do is you need to create a stack. Okay, so how do we create a stack here? Obviously by using array. Okay, so here you are going to create a stack using array. So how do you create a stack using array? Okay, so basically by initializing this array, okay, by giving some size to the array to like allocate memory location for that array, by that you are going to use that array as a stack here. You're going to perform operations in that array as how stack, like how the stack operations are. Okay, that we will see now how to do it. And you can see the structure of an empty stack here where I have used array. Okay, this is the array implementation of stack, and these are all the index values of the stack starting from 0, 1, 2, 3 and up to maximum size. That is what is the maximum size of an array. So array size -1, max size -1. So this goes on up to this, right? And here what is my initial top value whenever my stack is empty? Okay, I didn't insert any element into the stack. Your stack is empty now. So whenever a stack is empty, always the value of top will be initialized as -1, will be pointing to -1. Once you start inserting elements into this stack, okay, into this stack, then the top value gets incremented one by one. Right, so that we will start this by creating a stack using array. And this is the code for creating a stack using array. Here I have written it in 2 ways, so I'll explain you one by one. This is the first way. So when you're creating a stack, you need to do first like write a class for it. So this is a class, and the name of the class is stack. Inside the class you can see you're going to use an array, right? So you need to initialize an array first. So here we have initialized the array, right? And what is the name of the array? Stack array. Okay, for this stack array you created, like you allocated memory space by using this statement. You created a, like you allocated a memory location, okay, memory space for this. And what is the size of the array? That depends on this max size. Okay, so and what is the max size? Max size is already given here. And what is the size? It is 10. So now what is the size of my array? Size of my array is 10. Okay, and what is the name of the array? Which is stack array. So you created an array and you allocated memory for this array. And what is the size of the array? It is given as 10. Okay, so you allocated memory by taking the array size as 10. This is my first statement. And coming to the second statement, you can see what I have done here. I initialized the top value as -1 because initially your stack will be empty, which doesn't hold any elements in it. So if your stack is empty, always the top value should be what? -1. So that is what initialized here. When I am trying to create a new stack, okay, what I'm doing here, you can see in this main function, always your execution, Java execution starts from this main function only. So in this main function here, what I'm doing, I'm trying to create an object for the stack. Okay, so here is a class stack, and which means this class refers to this class stack. Okay, and here you're creating an object reference name stack. Okay, with this object reference you are going to like create one stack, and you'll be referring that stack with this name. This is the object reference for my stack, and here this new keyword is used to create a stack. Okay, and this is the constructor, so by which what happens, this stack will be called. Okay, the constructor, default constructor will be called here for this class stack, and all these gets instantiated once you call the constructor. Okay, all these gets instantiated. Right now the object is created, that is as new stack array is created here, and a memory is allocated for this. This is one way to write, and here is the other way where I am going to use a parameterized constructor. Okay, here you can see I didn't use any constructor because I'm calling this with a default constructor. Okay, so when I'm calling a constructor like default constructor, I don't want to like write it again separately inside the constructor. Okay, and if I'm going with a parameterized constructor, then I need to define my constructor. Okay, here I have defined my constructor. Actually inside this parameterized constructor, I'm going to instantiate all my variables. Right, so here you can see in this 3 statement we just have done the declaration part. So you're going to declare that you are using some variable called max size, which is of type integer. In the same way, you're going to use some one-dimensional array called stack array of type int, and then you're going to use some variable called top, which is of again integer type. So these things you are declaring that you're going to use in your program, and then where you're actually initializing all this, so all these initialization is happening here. Okay, that is you are passing some size for your stack, you are getting the size of the stack, and with that size you are going to do allocation. Okay, so here the size is given already, but here what you're doing, you're going to take size, and with that size you're going to allocate the memory for this stack. Right, the same thing, but just I'm getting the size here from this parameterized constructor. So in this case, how do you call this constructor? Okay, you can see in the same way you need to create an object reference for the class stack, okay, with the keyword new, And if you look at this constructor, here you are passing some value in this constructor. So this is the parameterized constructor. Okay, and this 20 is nothing but the size of your stack. Okay, so while calling itself, you are giving the size of the stack, which is empty, and this size will be passed here for this variable size 20, and this will be assigned here for this max size. Now max size will be holding the value 20. So now a stack array will be created with the size 20. Right, so this is the difference between the previous code and this code, how to create a stack using array. Now we'll see all the other operations of stack, okay, using array, right? The first operation is empty. You can see here for is empty, what is the return type I have used here? That is Boolean, because I told you in the previously, what you're doing with this is empty, you're going to check whether your stack is empty or not. If your stack is empty, it will return true. If your stack is not empty, then it will return false. So it will return a Boolean value anyways. For that reason, the return type taken here is Boolean. And here the condition you are checking, what is the condition you are checking? Top is equal to -1, because you initialize the top value as -1. And when does the top value is -1? When the stack is empty. So if you want to check whether your stack is empty, directly you can check whether the top value is -1 or not. So if top value is equal to -1, which means that your stack is empty. So it should return what? True. Okay. Otherwise it should return what? False. Okay, this is how you are checking whether your stack is empty or not. Okay, and then coming to next condition is full. So when does your stack become full? Once it reaches the maximum size you allocated for the array. So for example, if the maximum size of an array is given as 5. Okay, so the size of the array is 5 now, and it can hold 5 elements. But coming to the index value. So how does the index value starts and ends in the array with size 5? So it starts from 0, 1, 2, 3 and it ends at 4. You can see totally 5 elements can be stored into this array. Okay, and the index value starts at 0 and it ends at 4, which is nothing but max size -1. Right? So once my top value reaches here, initially top value is -1. Okay, if I insert a new element into the stack, okay, into this array, then this will be my top. Likewise, if I insert one more element here, my top moves. So in this way, if my top reaches this point, okay, then I can say that my stack is full, right? So here for checking the condition whether your stack is full, you are checking that whether your top is equal to max size -1. Okay, if it reaches max size -1, then it means that your stack is full. So you should return true, right? Otherwise, what you will do? You will return false. Okay. So this is how you are checking whether your stack is full or not. And for this also you are using the return type Boolean, okay, which will return either true or false. Now what is the next method? Okay, so the next operation is peek operation. Okay, so as mentioned already, peek operation means it will return the value that is present at the top of the stack. So when you are doing peek operation, the first condition you need to check is whether your stack is empty or not. Because if the stack is empty, if there is no element into it, you cannot return any element, right, at the peak. And that is why you are first checking whether your top value is equal to -1. That is if your stack is empty. If the stack is empty, just you are returning. You are not you are not writing anything. You are not printing anything as a result. Just you are returning back. But if your stack is not empty, it has some elements into it, then what you need to do? You need to return the top element. So how do you return a top element? Else condition, what you are returning? You are returning the top element. Where is the top element? That is present in the stack, that is present in the array, stack array. Okay, so the element that is at the top, okay, in the stack array will get printed. This is how the peek method works. Okay, you are trying to return the top element of the stack. And next is the push operation. Okay, first we'll see how push operation works and then we'll go for the implementation. Now take push operation. I just want to insert some elements like 5, 10 and 50 into an empty stack. So this is my empty stack where you can see the index starts from 0 to up to, like, if my max is 10, then it goes on up to 10. Okay, this is my stack size, for example, I am taking. And you can see the top value, which is -1 initially because the stack is empty. Now I'm trying to insert value 5. So if I insert value 5, my top value becomes what? 0. Okay, and in the same way, next I'm trying to insert 10. If I insert 10 into the stack, you can see again the top value is pointing to 10. The index position will be 1. And if I insert 15, then the top will be pointing to 15 and the index position is 2. In the same way, whenever you are trying to insert new element into the stack, always your top value gets what? Incremented by 1. So initially it was -1 and then it went to 0 and then it went to 1 and now it is at 2. So every time you are performing insertion and every time your top gets incremented by 1. That is what given here. So this is how push operation works when you want to insert any element into the stack. Right, so that's what given here. And for this, how do we write a code? And one more thing, I already told you the condition in push. Okay, whenever you are doing push, you need to check for this condition also, that is overflow condition. So what is an overflow? When a stack is full already, still you are trying to insert element into the stack which is full, okay, then that condition is called as overflow. Okay, so first you need to check whether your stack is full when you're performing push operation. If it is full, you cannot insert element into it, so you can display the message like overflow. And if the stack is not full yet, then you can go for inserting the element. So that's what given here in terms of code. You can see the method push where I'm trying to insert some item. So this is my parameter input for this push operation. The first condition I need to check here is whether my stack is full, that is whether the top reaches maximum size -1. If the top reaches maximum size -1, then you should print it is an overflow condition. Okay, otherwise what you are doing, so as I told, whenever you are performing insertion, the top value gets incremented. So you need to increment the value of top first. Okay, after incrementing the value of top, then you will be inserting the new item into that top position. Okay, so first you need to increment the position of top. After incrementing the position of top here, then you will be inserting the new item into this position. That's what happening here. First increment the value of top and then assign the item value to the array at top position. Right, so this is what push operation. Now we'll see the pop operation. Okay, pop operation means remove elements from the stack. So how do we remove element from the stack? For example, this is my stack now. I want to remove an element from the stack. As I mentioned already, always the top element will be removed first. That is last in, first out. So here if you remove any element, then you need to remove 15 first. So after removing 15, then what are all the elements left in my stack? 5 and 10. Now you can see the top position. So where is my top? Top is pointing to 10 at the position 1. And then again if you want to remove element, which element can be removed? Element 10 will be removed. If you remove element, again my top will be pointing to 5 at the position, index position is 0. So again if I remove this element from the stack, then my stack becomes empty. If my stack becomes empty, what will be my top value? Top will be pointing to -1. So you can see here clearly that whenever you are removing any element from the stack, always the top value gets decremented by 1. Okay, when you are performing push operation, top value gets incremented by 1. Whereas if you are performing deletion operation, I mean pop operation, then your top value gets decremented by 1. So for that, how do we write a code? Here is a code for pop operation, and when you are performing pop, again you need to check for the condition underflow. Okay, so what is an underflow? If your stack is already empty and still you are trying to delete element from the empty stack, so that condition is called as an underflow condition. So for checking that, you need to verify whether your stack is empty. So how do you check your stack is empty? So when the top value is -1, then we know that stack is empty. So that is what the condition you are checking here. If your top value is equal to -1, then you can say it is underflow. If you are trying to do pop, then it is an underflow when your stack is empty. Okay, otherwise if it is not empty, then what you are doing? So you need to decrement the value of top. Okay, so what you are doing basically, when you are trying to remove elements, you are decrementing the value of top. That is what done here, decrementing the value of stock. Okay, but before this, you can see I have added one more statement. What I'm doing in this statement, I'm trying to access the element that is present at the top, and I'm assigning it to another variable called item, which is again of type integer. Okay, so what I'm doing, before decrementing the value of top, okay, so I am taking the element, I'm fetching the element, accessing the element that is at the top of the stack, and then I'm trying to assign that element into another variable. So why am I doing is, just I want to display which element I have deleted. Okay, so obviously you know that the top element will always gets deleted first, but you do not know what is at the top of the stack, right? So you need to at least display which element you have deleted, right? So in order to display that element, before doing in decrement, I have taken that element and I assigned it to some variable. So after decrement, now you can see I just have displayed what element I deleted. Okay, element popped, then that element, whatever the element stored here, that will be displayed here. Okay, for this reason only I have done this statement. It is an optional, it is completely your wish, and it depends on the problem, like test cases. Okay, so if you want to delete the element that you have removed from the if you want to display the element that you have deleted, then you can do this, you can add the statement. Otherwise you can directly do this stop minus minus, no problem, right? So this is what the pop operation. And the next operation is display, okay, which is the last operation we'll discuss in this array, stack implementation using array. And coming to display, so how do you display elements from the stack? That is, this is my stack now. Okay, so the same stack, but I have drawn in this way, like in the array, in the form of array. So you can see here, these are all my elements in the stack. So 5 is at location 0, index value 0, 10 is at index position 1, and 15 is at index position 2. And now where is my top? My top always points to the last element, right, in the stack. See, when I'm trying to display the element of the stack, always it starts from this element, okay, because this is the point where top is pointing to. Okay, this is the element the top is pointing to. So always the display starts from here, this element. Okay, and then it goes to the second element, and then it goes to the third element. Okay, so if I want to display in this way, how do I display it? How do I do it? See, here again you see you are trying to iterate over the elements of an array, but in a reverse way. Okay, not from this side, but you are doing it from this side, reverse way. So how do we do this iteration? For iteration, I have used for loop. Okay, and inside this for loop, the variable I is initialized with top value first, because I am going to display the value that is present at the top first. Okay, so I have initialized with top. And what is it, what is the next value I need to display? The next value is 10, which is present at the location 1. So from 2, I'm going to 1, which means I'm decrementing the value, right? So here, that is why I have done I minus minus. I'm decrementing the value one by one. Then what is the condition I need to check for I? Okay, where do I stop? Where to stop this iteration? Once your I is greater than or equal to 0, then you can execute this. Okay, you can execute this block, you can do the iteration. But if this becomes false, if your I value is less than 0, if your I value becomes less than 0, then you have to stop the iteration. Okay, this is what the stopping point, this is what the stopping condition for this iterator for loop. Okay, so now what is the top value? Top value is, that is the index value is 2, right? So this is my top now, index value is 2, I value is now 2. Okay, and I'm checking the condition whether 2 is greater than or equal to 0. Yes, it is true. If it is true, go to the block. Okay, and here you are printing the value that is present at the top, that is I. So what is I value now? It is 2, right? So what is stack array of 2? This is stack array. So stack array of 2, what does it have? It has 15. Now 15 will be displayed, printed. Okay, after this it goes here, and the I value gets decremented by 1. So if you decrement the value of I by 1, then now my new I value would be 1. So now I value is 1. Again it checks for the condition which is greater than or equal to 0. Then it enters into the block. Now what is the value of I? It is 1. What is stack array of 1? Stack array of 1 contains 10. So this will display the value 10. Again it performs a decrement operation. I value becomes what? 0. It checks the condition. The condition is true. Enters into the block. What is stack array of 0? It is 5. 5 gets displayed. Again it comes here, decrements the value. Now I value becomes minus 1. 0 minus 1, that is minus 1. So once I reaches minus 1, it will check for the condition. Here I value is not greater than or equal to 0. But I value is less than 0. In that case, the condition fails and it will not execute this block. So this iteration will stop here. And these are all the values displayed, okay, from the stack. This is how display works. Right? So this is what the implementation of stack using array. And we'll discuss the implementation of stack using linked list in the next video.